Hi everyone, I'm Tan Chin Ling. Today I would like to present my paper titled Ion Chromatography Test in the Conservation of Fort Margherita, Kuching, Sarawak, Malaysia. In Malaysia, rising dampness is one of the most common building defects in heritage building, especially the masonry structural heritage building, which is built of bricks. The dampness or moisture brought the soluble mineral salts from the ground and damage the masonry building structure through capillary effect. The salt residue inside the columns, walls, and other structures will weaken its structural stability. Besides that, high salt contamination in masonry structures of a heritage building will cause extensive crumbling and damage of wall plaster, especially the lower part of the walls. According to National Heritage Act 2005, Act 645 and Guidelines on Heritage Building Conservation 2017, the implementation of scientific tests in heritage building conservation practice in Malaysia is encouraged and recommended by the National Heritage Department of Malaysia. Thus, ion chromatography test or salt test is conducted in heritage building conservation project to investigate the level of salt abandoned in the columns, walls, structures, and components of a heritage building. This paper is based on the study on documentation regarding the ion chromatography test conducted in the conservation of Fort Margherita, Kuching, Sarawak, Malaysia in 2012 to 2014, such as the ion chromatography test report and the final conservation report. The result of the ion chromatography test on the conservation of Fort Margherita, Kuching, Sarawak, Malaysia was evaluated based on the literature review on ion chromatography. The research findings reveal the purpose and basic procedure in conducting the ion chromatography in masonry heritage building conservation in Malaysia. Keywords: ion chromatography, conservation, masonry heritage building. This image shows the location of Fort Margherita, which is located near to the Sarawak River. Fort Margherita is located at Kuching, Sarawak, Malaysia. It is situated on a hill at the north bank of the Sarawak River. It was built in 1879 by Charles Brooke, the second Raja of Sarawak. Fort Margherita was named after Charles Brooke's wife, Rani Margaret. The conservation of Fort Margherita, Kuching, Sarawak, Malaysia was started in 2012 and completed in 2014. Ion chromatography test was conducted to investigate the salt contamination problems and to ensure the effectiveness of the salt desalination treatment. Desanot, Bonds and Shahid Jadeh in 2016 revealed that salt weathering affects the porous materials including the engineering structures, monuments, and artworks. Gaffa and Harris in 2010 reported that rising dams and salt attack are the common building defects in heritage building in Penang, Malaysia, where the existence of mineral salt may weaken the building components. According to Woofit in 2000, soluble salts are a principal agent which cause decay in porous building materials, and there are various types of soluble salts such as sodium chloride, carbonates, nitrates, and sulfates of calcium, magnesium, potassium, sodium sulfate, and magnesium chloride, which can cause damages to building masonry. Nianwei and Ajri in 2017 mentioned that sodium, potassium, magnesium, and calcium are common cations found in masonry wall, while chlorides, sulfate, nitrates, and carbonate are common anions found in masonry wall. Please refer to Table 1 and Table 2 later. Gaffa and Harris in 2010 stated that there are three types of destructive soluble salts which can be found in the masonry wall of heritage buildings, such as chloride, nitrates, and sulfate. All of these salts can be detected by ion chromatography test. Ion chromatography or ion exchange chromatography test or SOT test is a chromatography process that separates ions and polar molecules based on their affinity to the ion exchanges. Table 1 shows cations commonly found in masonry wall, which are sodium, potassium, magnesium, and calcium, while Table 2 shows anions commonly found in masonry wall, which are chloride, sulfate, nitrate, and carbonate. Research objective: to reveal the purpose and basic procedure in conducting the ion chromatography in masonry heritage building conservation in Malaysia. Methodology: the literature review on ion chromatography test was compiled from several sources such as the research papers, laboratories report, and interview sessions with the local heritage conservation experts. The case study data was collected from the final conservation report and ion chromatography test report for the conservation of Fort Margherita, Kuching, Sarawak, Malaysia. The data was analyzed and evaluated to reveal the purpose and basic procedure in conducting the ion chromatography in masonry heritage building conservation in Malaysia. Discussion and findings. In masonry heritage building conservation in Malaysia, ion chromatography test is conducted to investigate the level of salt embedded in the masonry brick wall. There are three types of destructive soluble salts, which are chloride, nitrates, and sulfate, which commonly found in the masonry heritage building. In practice, ion chromatography test is conducted in three phases, which are before salt desalination treatment, during salt desalination treatment, which are after the application of first round cocoon poticing, and before the application of second round cocoon poticing. And the last phase will be after salt desalination treatment. It is critically important to identify the salt contamination problem in masonry heritage buildings and to ensure the effectiveness of salt desalination treatment. The research findings identified that ion chromatography test has three major functions in masonry heritage building conservation. First, ion chromatography test is applied to identify the salt contamination problem. Second, it is an important test to investigate the level of salt embedded in the walls, columns, and other building components and elements. Furthermore, ion chromatography tests also play an important role in determining the effectiveness of salt desalination treatment. In conservation of brick masonry heritage building, brick dust samples are required for ion chromatography tests. The brick dust sample were collected from 4 spots on masonry walls of Fort Margherita, Kuching, Sarawak by drilling at 3 different depths, such as 10 mm, 20 mm, and 40 mm on the spot. The test was conducted for 3 stages, which are before, during, and after the salt desalination treatment process. All the sample collection spots were recorded on drawing and report for future reference. It is crucial to avoid sample collection during the rainy day. The sample should not be polluted before and during the process of ion chromatography tests at laboratory. Salt desalination treatments for Fort Margherita, Kuching, Sarawak is considered effective as the total salt content was reduced after the salt desalination treatment. Please refer to Table 6. Table 3 shows ion chromatography test result of samples at location 1, which collected before salt desalination treatment. Table 4 shows ion chromatography test result of samples at location 1 collected after first cocoon application, while Table 5 shows the ion chromatography test result of samples collected at location 1, which is after second cocoon application. Table 6 shows the summary of ion chromatography test result for Fort Margherita, Kuching, Sarawak. The ion chromatography test results show that the total salt contents were reduced after the salt desalination process. Conclusion. In conclusion, all decision-making process in heritage building conservation should be supported by evidence-based approach. Salt attack or salt contamination is one of the major building defects found in Fort Margherita, Kuching, Sarawak, Malaysia before the conservation works in 2012. The soluble salts will affect the structural stability of the masonry heritage building. It should be removed from the masonry heritage building to safeguard its architectural value and authenticity. The ion chromatography test can assist in identifying the building defects such as salt contamination, investigating the level of salt abandoned in the walls, columns, and other building components and elements, and ensuring the effectiveness of the salt desalination treatment. That's all for my presentation. Thank you.